Welcome to a model logic demonstration of a processing plant. In this video, we will cover how Simio mimics the real-life behavior of a mineral processing plant in order to accurately produce results for informed decision-making. This is a Simio model of a small comminution plant consisting of a crusher, conveyor, bin, and screen. In the course of the video, each part will be briefly broken down with simple explanations. So we'll start at the beginning with the input flow. Each component in the system has a design capacity, and in this case all components are set to 500 tons per hour. Each component has its own failure profile modeled using the mean time between failures, or MTBF, and a mean time to repair, or MTTR. The plant as a whole has a maintenance schedule as well. This model contains a crusher bin, crusher, screen, recrush conveyor, and feed conveyors are used as well. The process is labeled according to the key performance indicators, or KPIs, that are deemed most important for that process, such as each component having a maximum operating rate or design capacity. Other views include triggering levels for the crusher bin, as well as the current feed rate into the crusher. The screen in this example will produce different splits according to the particle size distribution, or PSD, that it receives from the crusher. Applying a Witten function, it will then produce an under and oversized PSD. The mass split is also calculated shifting the mass balance as the PSD changes. Based on historical data, the MTBF and MTTR mentioned earlier, failures can and will occur, as is their nature at unpredictable times. This unplanned downtime, as shown here with the red-colored screen, will evidently affect the entire process. Visual indicators play a big role in understanding what state a process is in at any given time, which makes analyzing the system a whole lot easier. In this example, red indicates a process that is failing. Yellow indicates a consequential delay, such as it being blocked. Other colors represent other states, such as it being busy, idle, in maintenance, or the plant is in downtime. A large benefit of Simio, as well as the other dynamic simulation packages, are their ability to run a process over time. The current flow rate here through each component can then be monitored throughout the entire run. When the crusher bin reaches its high mark, the feed into the bin is stopped as part of the plant control philosophy. KPIs such as availability, utilization, and throughput can be reported from a per second basis all the way to a per year basis. In conclusion, a simulation model is an effective method of representing a processing plant and its various components. This conceptual model can then be extended to match any processing plant scenario with accurate results, and will allow users to test various what-if scenarios without any risk by using it on this digital platform.